Okay, thanks a lot. Okay, so hi everyone, thanks for joining us. My name is Moin, I'm a senior software architect, and I have my colleague Bistat with me. Today we'll be talking about securing Node.js applications end-to-end. Just to give you a quick intro to you about us. Okay, I need to turn it on. Okay, let's see. Okay, good. Okay, so quick intro about us. Both of us are part of Thales. We are part of its cloud protection and licensing division. Originally, we were from Gemalto, but Thales recently acquired Gemalto earlier this year. Both Thales and Gemalto, I'm not sure if many of you heard about that because it's not a household product name. Most of our products are enterprise focused. They are more B2B as opposed to consumer focused. Currently, we are working on a product called SafeNet Trusted Access, which is essentially an identity and access management product. And it's a distributed product which has a lot of microservices. Some of our microservices are built using Node.js. And since Thales is a security company, we have a strict set of requirements that we need to, there's a strong emphasis on security first. So we have strong, strict requirements in terms of their predefined activities that need to be performed while you're developing the application or when you are, before you ship those to production. So purpose of our talk today is to share some of those mechanisms available in Node.js, which you can use to address some of the most common security issues in your applications. So hopefully that would be helpful. So before I talk about the agenda, I wanted to know the audience a bit better so that we can pace our talk accordingly. Can we do a quick show of hands to see how many of you are developers here? Okay, good. What about architects? Do we have any architects here? Okay. Do we have anyone here who has been using Node.js professionally? Okay, quite a few. That is expected. Good to know. Okay, so what we'll do is we'll only we'll do a very quick overview of the Node.js. We won't go into details. We'll try to focus more on the security aspects of it. So once overview is done, we'll directly jump to the different security issues, the common ones at least, and we'll see how they can be addressed in Node.js. And towards the end, I'm sure we'll have enough time to take your questions and we'll address those at that point. So let's start with the overview.
So Node.js is a JavaScript runtime built on Chrome's V8 engine. It's single-threaded, has an asynchronous, event-driven architecture, which makes it very performant when it comes to processing concurrent tasks. We use it for anything from server-side scripting to server-side web development, making big REST APIs. It is cross-platform, so what we can do is we develop on Windows and deploy in Linux when it goes to production. It has a package manager, NPM, which has many libraries. One of the things that makes Node very popular with developers. It has many libraries under MIT licensing that's free to use. It's used by some of the biggest companies, Thales, Netflix, and LinkedIn. Along with Express, there's a very popular web application framework called, along with Node, Express. We mainly use it to do REST APIs, which it also comes with many middlewares. Middleware is pretty much software that sits between HTTP module and your controller. It lets you augment your code to add security, to add any kind of processing that you can give off to third-party libraries. So this is a Hello World example using Express and Node. You pretty much create your Express instance, you attach it to the server, you create a controller, in this case, that returns Hello World, and then you start listening on port 8080, and that's pretty much how you can create the Hello World. Now that we have an introduction out of the way, our first topic is TLS. So the most important thing you can do to secure your web application is to use HTTPS. There's a common misconception that your clients connecting to your web application go through either a load balancer or a web application firewall, or your WAF, so you can have your TLS terminate at the WAF. But in actuality, we should follow the defense in depth concept and encrypt communication within our servers. So if we have your web application communicating with the Redis or with your database or whatever other services you have, you should have a TLS communication between those. So after you enable TLS or HTTPS communication, some of the things you should do is you should disable insecure protocols. In this example, he listed SSL version 3, TLS 1, and TLS 1.1, and you have to keep them up to date to make sure that the insecure or outdated protocols are disabled. Also, the insecure ciphers. That's an example here, RC4, MD5. If it's not already disabled by Node or by your system that you're using, you should make sure to disable it. Listed 2 tools here. One tool you can download from testssl.sh, another web application provided by sslabs.com, which will connect to your web application and will test that if you have any insecure protocols or insecure ciphers that are enabled on your HTTPS connection. Here an example of how to enable HTTPS in Node. Basically, instead of using HTTP module, you use an HTTPS module and you pass it a credentials object. You just provide a key, a certificate for the key, and a passphrase that secures the key. If you notice, we don't have the passphrase as a string in the code. It's stored securely and passed securely to your application. We also pass secure options to disable SSL version 3 and TLS 1, and also pass a ciphers which sets which ciphers we want to use and which ciphers we want to disable. Like I said before, you should use TLS for your downstream services. So if you have many services, especially even if you have that many, you might not want to have a public key certificate signed by a public CA, which can be expensive. So what you can do is, you can use privately signed, a certificate signed by a private CA, but then use a custom trust store, like so. Here we have a certificate signed by a private CA. We just pass it to the global options CA. You can use TLS even in the intra-servers without having an expensive certificate.
Okay, so when you are trying to secure your web applications, there are many things to consider, but probably one of the easiest way to start is by looking at your HTTP security headers, because they provide you another security layer which helps you mitigate some of the security issues. And generally speaking, irrespective of what technology you are using, they are also very easy to configure. And Node.js is no exception to that. We have a package called Helmet in Node.js, which lets you manipulate all those security headers very easily. And it's very easy to configure. You just install the Helmet package, and then you can attach that as a middleware with your Express application. So, okay, I saw somebody was taking the picture. Okay. So Helmet is essentially a collection of a lot of middlewares. Each of those middlewares let you manipulate different security headers. One thing, and I'm not going to cover all of those here. I just listed them as a reference. I'll try to focus on more the key ones. But one thing which I would want to highlight is when you use the Helmet the way I did in the last slide, it automatically enables some of those middlewares by default, which you can see in the last column. But having said that, you can also disable or enable additional middlewares if you want to. Those middlewares which gets added with the default configuration. If you want to modify that, you can also do it. There's another way of using the Helmet is, rather than using the middleware like I did, you can individually use those middlewares if you want to. So all in my next examples, I'll be showing those individual middlewares just for the sake of it, but you can use both approaches, that's up to you. So let's start with the strict transport security header. So that's a security header which enforces the browser to always use secure channel of communication with your web server. The benefit of that is if an attacker tries to downgrade your protocol to use unsecure channel like HTTP, the browser will reject that. So the good thing about this, it's supported by most of the browsers. One thing though you want to look into is it's only supported from IE11 onwards. What it means that is even if you are setting the security headers, and if your users are using older version of IE, it won't do any good for them. So what it signifies is that just setting those security headers are not enough to mitigate those security issues. You also want to augment that with some other mitigation approaches. So using that, it's very simple. Again, simply use the Helmet's HSTS middleware. And here I'm just using one configuration, but you can use more configurations which are available. Here, basically, I'm just setting the max age to 60 days in this case. So Xframe options is another important security header which helps you prevent against the click checking attack by letting you define which are the applications which can embed your application as an iframe. By default, when you use Helmet, it would deny that for all the applications. But for some reason, like if there are business requirements and you want to allow that, you can explicitly whitelist those hosts as an application which can embed your application as iframe. Again, good thing is it's supported by most of the modern browsers. Okay, I forgot IE11 as well. Yes, so it's supported by modern browsers as well as IE11 as well. So to use that, it's simple. Again, use the FrameGuard middleware. Here, if you look at the example, I'm explicitly allowing it to use, I'm explicitly allowing my application to be embedded as part of example.com. If you look at the bottom of the slide, there are two versions of that header I'm showing. One is where it's deny. The second one is much closer to what my example is there up in the code. So let's talk about the content security policy. In my opinion, that's one of the most important one because it helps you protect against the XSS attacks. And again, I'm sure since we are at LessCon, you are guys familiar with OWASP. XSS always feature in OWASP top 10, and I was reading the latest stats. It seems they are 2/3 of the applications were vulnerable to this attack as part of their last analysis. So the beauty of this content security policy is it helps you protect against XSS as well as some other injection attacks by letting you define it lets you whitelist the sources from the content can be downloaded from your website. Just to illustrate that point a bit further, if you look at the example down there, I have an website where the content security policy is configured in a way where anything from example.com is a valid source. What it means that when the browser would be asked to download the JavaScript or CSS from example.com, the browser would allow that. But when you would try to download something from malicious.com, which could be because of an XSS attack or whatever, the browser would automatically reject that because that is not part of the whitelisted white sources over there. Again, good thing is it's supported by most of the browsers. One thing to note is it's only supported from IE10 onwards. Again, to use that, again, same convention, use the Helmet's content security policy middleware. Here I'm just using a couple of directives, but CSP has a lot of directives. So if you're not familiar with that, I seriously encourage you to go and check those middlewares. Look into those content security policy since it protects you against the XSS attack, so it's definitely worth looking into. So here, basically in the example, what I'm doing is I'm defining the defining the valid sources for my scripts, as well as for my style sheets, and for everything else like your images, fonts, iframes, I'm saying only allow those things to be downloaded from my website, reject everything else. So the next one is the XSS protection. So this one is basically, there are few browsers, a couple of browsers which has some built-in support for XSS protection, and this header lets you enable that. One thing important to understand is these browsers don't provide you complete coverage. They only give you protection against some simple XSS attacks. So, but and you can see it also from the browser support. It's supported across Chrome, IE, 8, and Safari. But it's not supported on Firefox or Edge, for example. But the thing is that as long as your website is implementing content security policy, you really don't care because you already have the CSP gives you better coverage of against the XSS. So one question I probably would ask is, if my website is already implementing content security policy, then why even I'm discussing that? Do I really care about this? if CSP is implemented, do I need to implement that? My answer to that is yes, you need that. Can anyone answer that, why I'm saying it? Anyone in the audience? Okay, so the answer is CSP policy is only supported from IE10 onwards. Okay, whereas this one is supported from IE8 as well. So you want to combine both those things together so that at least for the older version of IE, you have some coverage there. Okay. Another thing which I want to highlight is even if you implement both security headers, will it give you the complete protection against XSS? It won't. So you want to implement, again, as I said earlier, you want to implement other mitigations to give you complete coverage. So the better way of doing it, other than these security headers, you want to implement input validation as well, so that gives you more coverage, more protection against this vulnerability. Okay, so we'll be talking about that a bit more later in the slides. X content option type options is, that's a security header which tells the browser that it should not try to guess the MIME type of the file returned by the server. So just so you know that MIME type is basically a way of server telling the browser what's the type of the file it's looking at. For example, for a PNG file, it would be image/PNG. For JSON file, it would be application/JSON. What happens is there are a couple of browsers, what they do is, rather than relying on the MIME type returned by the server, they try to look into the content of the files and try to guess the content out of that. So now, and that could lead into some of the security vulnerabilities. So imagine a scenario where an image file got uploaded, there is the, and it has an extension PNG, which is fine, but the content of that file is actually an HTML. Now when you go to that image in the website, that may execute the HTML, which could contain some malicious code. So what you want to do is, that's where this security header comes very handy, that you want to tell the browser, okay, don't try to guess the content of the file, rely on whatever the server is telling you is the file type. Okay, so that's where this would be handy over there. Okay, the last security header that I want to talk about is X powered by. So far, all the security headers that I talked about, I was saying, okay, you need to add the security header to improve the security of your application. But in this case, what our suggestion is, either remove the security header completely or change its default value to something else. Generally speaking, this security header tells you what is the technology being used to serve the web server over there. And this is an information which attackers can use for their advantage. They can be more targeted in their attacks. So what you can do is either remove that completely from the response, or change it to something else like PHP. Let fool the attackers over there, let them target their energy on PHP specific attacks, which will hopefully won't trouble your application.
So if you have authenticated sessions, then it means you have a session to manage. A strong password or two-factor authentication would be useless if an attacker can get access to your active sessions. So we must protect the session. So one of the most important ways to protect your user session is to make sure the session cookie is not sent over HTTP. What you have to do is you set the session cookie to be only sent over HTTPS. There was a case in 2016 where Facebook had the user session being hijacked. As it turns out, users were connecting to Facebook, authenticating to HTTPS, but then downgrading to HTTP, while at the same time using coffee shop Wi-Fi or any unsecured Wi-Fi. What hackers were doing, they would sniff the network, capture the session cookie, and then take over the account. Second thing, you should make sure the cookie is not accessible by JavaScript in the browser. One of the things is JavaScript running in the browser has no need to access the session cookie. Two, if you have XSS vulnerability and your cookie is the session cookie is accessible in the JavaScript browser, the XSS can capture the session cookie and pass it on to the attacker. Third is to change the cookie name to some custom value so an attacker won't be able to fingerprint the system you're using to manage the session. So here we have an example of how we use Express Session to manage our cookie. The secret, it's a value used to sign the session cookie, which prevents an attacker from creating a fake session cookie. It's especially important in the case when you have the client, the session cookie stored on the client side. If the entire session is stored on the client side, then an attacker can make his own, assuming your secret is weak or he has access to it. The name, we set it to my session ID, which prevents fingerprinting. It's not a generic name that everybody else uses. The cookie, secure QQ flag, lets the browser know that the cookie should not be sent over HTTP. After you authenticate, if you do downgrade connection from HTTPS to HTTP, then this cookie will not be sent. HTTP only flag lets us know that JavaScript running on the browser should not have access to the session cookie. Your users intentionally or unintentionally can send too many requests to your system. Normally, this brute force or denial of service is handled at your web application firewall, but you can augment the protection that's given by the WAF on your specific APIs by adding either throttling or rate limiting. So throttling would just delay the response from requests in order to slow down clients that send too many requests at a given amount of time. And rate limiting outright rejects clients that send too many requests. Normally slowdown would create a lot of open connections if you have too many slowdowns happening, and a user can cause a DOS on your system by creating a lot of connections and keeping them open. So what we can do usually is to pair throttling and rate limiting in order to slow down clients, but for up to a given limit, after which you start denying requests. So here we have an example of throttling and rate limiting being used at the same time. We create a slowdown configuration that allows 5 requests in a 15-minute window, after which 100 millisecond delay is added, which means the 6th request would take a 100 millisecond delay, the 7th, 200, the 8th, 300, etc. And then we create a rate limiting configuration that only allows 10 requests in a 15-minute window. When we pair them up, what will happen is a user that sends too many requests will be delayed by 100, 200, 300 milliseconds all the way up to the 10th request, after which the request will be denied with a 429 error.
Okay, CSRF or cross-site request forgery, as you all know, it's also one of the common vulnerabilities found in the web applications. I remember it used to be part of the OWASP top 10, but I was surprised it was not part of it anymore. It turned out that since a lot of application frameworks are providing support for that out of the box, and with the usage of those application frameworks and built-in support, the number of applications found vulnerable to this attack got reduced. So key takeaway from here is, okay, let's make sure we keep on using those built-in functionalities over there so that it does not show up in the next OWASP top 10. So those who are not familiar with the cross-site request forgery, it is basically an attack where the attacker forces the user to perform some unwanted actions on the websites where they are already logged in. A very classic example of that is a user is already logged into the bank website and the attacker forces you to transfer some of the cash from your account to the attacker's account. As I said, applications are providing out-of-the-box support for this. Node.js is no exception to that. There is a CSRF, there's a middleware called CSRF, so you install that. Once you configure it with your application, it would automatically generate a random CSRF token for you, would write that in a cookie, and then after that, it expects that token to be present as part of every post, put, or delete request coming from the browser. And then over there, what it does is the middleware would automatically check the existence of a valid token as part of the request. By default, it would look into the, as a body attribute, it would look for _CSRF, and there are a couple of headers where it would look for that. Again, these are the default values, but you can obviously change that if you want to. Just to show you an example of that is, if you notice here, I'm using a CSRF protection middleware, and I'm telling it to use the cookie equal to true, use the cookie option. What it means that is, it should generate the CSRF token and write that in a cookie. And to do that, I also need to use another middleware, which is called cookie parser. which is letting my application, which is helping my application to manipulate the cookies over there. Once that is done, I can now configure this middleware with all the routes where I want to use that. Here I'm using it explicitly for CSRF, for /form as well as /process. Here I'm explicitly specifying that for each of the routes. But if you want to, you can very easily centrally define that by using the regex. You can centrally define it and mention all the routes where you want to apply that, so that you don't need to worry about that for each endpoint. Now, if you look at the /process endpoint, one thing important to highlight here is this middleware, the CSRF protection, would automatically look for the existence of a valid CSRF token. If it's there, only then it will proceed. Otherwise, it will reject the request automatically. So from the developer perspective, it's making our life very easy in terms of we don't need to worry about that handling it for each method, that this middleware is going to take care of it for us. And the other thing is, as part of the /form endpoint, I'm also passing the CSRF token explicitly right now to the model attributes. So let's look into the UI code of that, and that will make more sense. So if you look at over here is I'm assuming I'm showing a very simplified version of the example, where it's a HTML form, and here I have a hidden input field, and this is where I'm using the CSRF token passed from the controller. And when the form would be submitted, this value would be part of the request as well. Now, technically speaking, there is one issue that I see with this approach, that what it means that for every request, every page which needs to be rendered, now you need to pass the CSRF token over there. Technically speaking, you don't need to do that, because you already have the CSRF token as part of your cookie. So what you can do is you can, technically speaking, automatically extract the token from the cookie and have something middleware or something written on your JavaScript or UI side to automatically pass that as part of the request. And this is let me complete that and I'll address that. So, and this is something which some of the middlewares are doing it. Some of the single page application frameworks are already doing it. Like Angular, that's one of them. Is it already supports this mechanism where it reads the value from the cookie and then inject that as part of the request. Benefit of that approach is it makes it very seamless for the developer even on the UI side. So both on the UI and backend, you don't need to worry about explicitly managing the CSRF token for every request the UI needs to send, or at the backend you need to validate. I was not saying that you should verify the cookie. Okay, let me go back to this slide. Okay, here I'm not checking the cookie for, so what I'm expecting, the value of the token should be part of the request headers or the body. I'm not verifying it based on the cookie. The cookie is only being sent to the UI so that UI can extract the token out of that, but it needs to still send that as part of the request headers or body, okay? Yes, so makes sense. We should not be relying on the cookie to verify that. Obviously that defeats the purpose, right? So, good question. Okay.
Let's talk about info validation. So, injection is number one in OWASP's top 10 vulnerabilities, and the best way you can prevent injection is one of the best ways to prevent injection is to do input validation. Injection is any unintended execution of code. It could happen from any input coming from the user. So any input coming from the user should be suspect and should be validated. It can cause data loss, data diversion, and it's one of the most damaging things that can happen. Unlike XSS, which can affect one of your users, injection affects your entire system and all the users in your system. So one of the things you do is you have to validate your input early in the controller before you waste any CPU cycles on the data before it gets to any of your business logic. You should log your input validation failures, because that's the only way you can tell if you have any false negatives and or any ongoing attacks that are happening in production. Like I was saying, any input coming from the user could cause an injection. Header, query, param, cookie, and file uploads example I've set here. Normally, the browser controls the header and the cookie, but a malicious user can modify these to cause an injection attack on your system. Alternative to rejecting bad inputs is to sanitize, so that you can keep the values that are okay and keep out the rest. Here an example of how we validate input using Express Validator. We use the Express Validator middleware, and then in our controller, we check the ID param and the name query. The ID is checked to make sure it's a base 64, and the name is checked to make sure it's between length 10 and 128. After which, if there's any errors, we return with a 400 along with the errors found. In order to sanitize, we can just augment our previous example by calling the whitelist function. What it would do is, from the name value, it would strip all the characters that are not within the given list. And then you can, instead of rejecting, you can keep the value.
Okay. So far we talked about different mechanisms which you can use to make your code more secure in Node.js. But generally speaking, our applications have a lot of dependencies in Node.js. What about those? Do you feel that your dependencies are secure? What about your dependencies of dependencies? Okay, actually, this reminds me that since I'm at LessCon, and I believe I was reading the speaker agreement somewhere, that I need to bring up OWASP every 10 minutes. So that's the time now. So yes, using the components with the known vulnerabilities is also one of the, also one of the top 10 issues of OWASP. And when you use a component with known vulnerabilities, that can also impact the security of your application. So as Biswat was saying at the start, NPM has a great repository which provides a lot of things out of the box, and that makes our life very easy as developers, that we can more focus on the business requirements rather than implementing on those common functionalities which are already available there. But that comes at a cost, that if those components have some security vulnerabilities, that can affect your application as well. And some of those vulnerabilities are unintentional, which are most of the cases, but some of those could be intentional as well. There are some cases where some of the contributors end up committing malicious code on purpose. So just to give you an example of that is, those who have used Node.js, I'm not sure if you are familiar with this, but it's an interesting thing to be aware of. So there's a package called event stream. It's a very common package. It's basically a toolkit which lets you manipulate the data streams very easily. And it's a very popular package. Last week I checked, it was still getting like 1.5 million weekly downloads. And it's dependency of one of the very common packages like gulp, which those who are using Node.js must be familiar with. It helps you automate some of your development workflows. So what happened last year, there was a new version of this package got released, and the contributor ended up adding a new dependency called flat map stream. Okay, nothing unusual. But it turned out the modified code was stealing the Bitcoin from the developer's machine and was reportedly transferring those funds to a server located in Kuala Lumpur. And the crazy part for me is this remained undetected for 2 months. For 2 months, nobody was able to figure it out. And the main reason was the flat map stream code was encrypted over there. So nobody was able to figure it out until a researcher was able to get into that and figure it out. So what should we do as developers? Should we forget about all the packages which are there in the NPM repository and start writing everything from scratch? Okay, obviously it doesn't make sense, right? So what you want to do is you want to invest in some vulnerability scanning tools. And there are a bunch of those available. I just listed few of those. There are few free tools available, few commercial tools available as well. I'll be mainly focusing on NPM audit, but there are few commercial tools I listed, which I found seems to be the most famous one. Again, I'm not endorsing any of those, and I want to be very clear, I'm not gonna get any cut out of their sales, so up to you guys to try it out. So for NPM audit, a quick history on that. There used to be a product called Node Security Platform, and its main responsibility was to check your installed Node modules and look for known vulnerabilities against an open source CVE database. What NPM did, it ended up buying that product, and then it shipped that as part of the NPM, started shipping it as part of the NPM out of the box. So as a developer, it was very good for me. When I'm installing my packages, it was already checking the vulnerabilities for my packages over there as part of the NPM install. I don't need to do something separately. It was already telling me, okay, once the package is installed, how many of those have vulnerabilities over there. So that was telling you out of the box. You don't need to do something extra for that. What they did even better, they went one step ahead and they introduced a command line utility to even fix those vulnerabilities for you. So just to show you an example, I ran this tool on one of my sample project, It identified there are 135 vulnerabilities with 100 plus as high vulnerabilities, 1 critical. And again, keep in mind, I'm just showing you the summarized view over here. When you would run that, you would see there's a big output there telling you for each of the vulnerabilities, what's the path over there, in which version this is patched, etc. So it would give you more details. Now, when you run the npm audit fix, it was automatically able to upgrade 4 of my packages. And if you, not sure if you can see it, it was able to fix more than 50% of the vulnerabilities it found at the first place. And for other 3 packages, it said, okay, those 3 packages are available, which should fix the issue, but they contain some of the breaking changes. And mainly the breaking changes, the criteria for them is if there is a minor version upgrade, they would upgrade that automatically. For any major upgrade, they won't upgrade that automatically, would tell you that it's available, you can upgrade that manually and try it out. There's an option to force the upgrade as well in that case. Again, that's not recommended because you want to be, when you are trying to figure out the breaking changes, you want to probably upgrade them one by one. Upgrade one, verify it's still working for you, then try to upgrade the second one. So that if there is some breaking changes, you can identify that easily.
So in addition to the recommendation we already made, some of these you want to do is you want to make sure you're not storing any secrets in code or in clear anywhere. It could be your passphrase or your key. It should not be in clear anywhere in your system. It should be encrypted. You should also not store it along with your code in your repo. What you can do, you can use Vault or an orchestrated managed system to store securely and also get it to your running application. You should catch exceptions, especially in the case of Node, since it's a single-threaded application. Exceptions that bubble up to the top can cause your application to fail, and any user input that can make your application consistently crash can cause a denial of service on your system. You should make sure your stack trace is not sent to the user. If a user can see how the internals of your system is, he can hone attacks to your system and make it easier to take it down. You should you should add logging to your system, and you also monitor it in production. If you don't log it, then you cannot tell any issues that are going on. It makes it very difficult to trace any issues. On top of that, if you don't monitor it, you will not be able to detect any ongoing attacks or issues you might have in your system. So to summarize, you should use end-to-end encryption in your system. You should configure your HTTP security headers to utilize the security provided by browsers. If you have authenticated sessions, then you must secure the active sessions. Otherwise, it will be the easy entry point for attackers. You should augment DOS protection provided by your WAF by adding throttling or rate limiting to your specific APIs. If you have put, delete, post, or any side effect endpoints that cause side effect on your system, you should add CSRF protection to them. Input validation is one of the best ways to prevent injection attacks on your system. Last but not least, you should check third-party dependency vulnerabilities, because any vulnerability in third-party libraries that you use can cause security holes in your system. Thank you. Now it's time for questions.